Hi, you're listening to the NewSpace India podcast, a bi-weekly talk show that exclusively brings insights from the Indian space activities ecosystem. I'm your host Narayan, the co-founder of India's first space-focused think tank, Spaceport Sarabhai. Guests on the NewSpace India podcast help you understand space activities-related macro and micro trends within India in all aspects, including space history, local industry, space science, technology evolution, law and policy, art, and more. The NewSpace India podcast is supported by Dassault Systems, a global leader in providing businesses and people with collaborative virtual environments to enable sustainable innovations. Dassault Systems Solutions supports startups, small and medium-scale enterprises, and original equipment manufacturers in developing disruptive solutions for space launchers and satellites.
I am George Joseph. I started my research career at the Tata Institute of Fundamental Research in Mumbai. And I have been working on carrying instruments with balloons to study cosmic radiation. And in 1973, I came to Ahmedabad, joined the Space Application Center. Before I get into the detail, I would like to give some background how Space Application Center started. During the unfortunate death of Sarabhai, during those days, activities in Ahmedabad were scattered in different places. After when Professor Dhawan took over as chairman, he consolidated everything and put together as a Space Application Center. Now, those days there are two major activities, one relating to communications, other relating to the remote sensing. But the remote sensing activities were initially those days were carried out under the leadership of Professor P.R. Pisharadi at the Physical Research Laboratory PRL, which is initiated by Vikram Sarabhai. Now, this was shifted to Space Application Center in those days, and communications activities were little more in advanced stage, but remote sensing was in the infant stage. So when Professor Yashpal took over, he found it is necessary to have all facets of remote sensing under one roof, which is a unique concept which you won't find anywhere else. Now, for example, you require a camera to develop a camera or an instrument to collect the data from the aircraft or the spacecraft. Then this data has to be converted into computer compatible tapes or the photographic product for analysis. And then this data has to be actually utilized by the end user. That's what the real purpose is concerned. So, Professor Yashpal decided to bring in people to head these three activities. It so happened that all these three people came from TIFR. Now, I was invited to develop the instrumentation, basically Earth observation cameras. Mr. D.S. Kamath was a computer expert, and he was the person who developed the first computer in TIFR to develop data processing and product. And Dr. Baldev Sahai, who will look after the applications. So just a little bit digress a story. So I was working with Professor Yashpal on a program which called infrared astronomy. So one afternoon he called me and said, then I thought he is going to discuss something about the experiment. So I took all my files, notes, etc., came to him and he listened everything. To my surprise, he said, George, I want you to come to Ahmedabad. So what I will do, sir? I said, no, you will do work on remote sensing to develop the instrumentation. Well, at those times, to be honest, I didn't know much about remote sensing, except it's meant for weather, and my knowledge of easterly and westerly is rather poor. So he said that you come and talk to Professor Pisharedi. And so one fine morning I got a ticket to come to Ahmedabad. So I came and had a discussion with Professor Pisharedi, who explained me in such a possibilities. So it appears, if you want to do anything, it has to be remote sensing. So that's how I was inducted. But then I had a little problem leaving TIFR because I was deeply involved in developing the payload for the Aryabhatta satellite, which was my thesis instrumentation. But then my boss there was worrying how this will be completed. Anyway, one fine morning, I got an appointment order. So I landed in Ahmedabad. Now, why this is Professor Yashpal's concept of all the three phases coming together under one roof was very effective. You will find in the later my talk. Now, this is a unique thing because if you want something to happen, something productive to the end user, you should have all the facets of that. Now, he had such a foresight. He said it's not enough that you develop this technology in-house. You should know what the user wants. And user should know what technology can be provided. So, he has instituted what is a small called user cell, which later Arup Dasgupta was heading that probably. So, this is a concept which is originated right from the beginning in all the space activities, that space is not for developing in-house things, but the fruits have to go to the national development. This is how the Space Application Center evolved as far as the remote sensing activities are concerned. Now, let me digress a little bit and talk about remote sensing origin at a national level. I think in 1969, Professor Sarabhai had wanted to have a meeting with then Prime Minister Indira Gandhi. So he got an appointment of 3rd March 1969 and he went there with a group of people to present what what space can do in general and remote sensing in particular. So he got half an hour, but the discussion went for hours. And the discussion was over. They came back to PRL. Professor Pisharedi was the main person explaining all these things. So Professor Pisharedi next day was a little concerned and worried, went to Professor Sarabhai and said, "Sir, we talked about so much in detail to Madam, to Prime Minister, that what we can do. But she never said that you go ahead." Sarabhai's answer was, she never said don't do it. So it is an acceptance. You go ahead with the work. This is the typical way in which Sarabhai used to, to get things done in the front and bridging the gap between the administrative requirement and the scientists. So then one of the participants in that meeting was M.S. Swaminathan, who was in charge of ICRE, Agriculture Research. So he came and talked to Professor Pisharedi, let us find out how this is effective in our condition. So what he suggested is, in Kerala, there is coconut trees. I've got a disease called coconut wilt, which affects the top portion of the coconut, and you can't see it unless it is progressed by the time the damage is already done on that. So that was the first experiment carried out in the remote sensing, and it was done on a helicopter. So then they could clearly identify, using multiband cameras, they could identify the coconut wilt trees. But then they found out it is rather difficult to operationalize because each individual tree is getting affected onto this thing. But Professor Pishardi, in the lighter vein, those days we didn't have any equipment. So we had to get the camera from one place, expert from another place, developing from another place. So Sarabhai, in his later sense, he used to sell, because I want to narrate this, will be interesting. So he used to make a comment that this of a true international character of the first remote sensing experiment by India. The camera was Swiss made, the film was made from UK, the helicopter was from Russian, an expert from USA helped, but the brain behind the experiment was Indian. Of course, coconut tree was also Indian. So this is the beginning, you could say, the first experiment which has come on that. Then following that, a lot of joint experiments were done with users to find out how effectively remote sensing can be applied for national development. So the thrust in all these things were, don't do things by ISRO, but you have to get involved in the users onto these things. Now, coming back to the developmental effort of cameras, which I was deeply involved in. So when initially there was only a single band thermal camera, which Professor Sarabhai got from France because of his personal contact, which was used to measure the sea surface temperature. Those days, that was a very important thing to find out the temperature of the ocean, which can be linked to the monsoon. So when I came to Space Application Center, the first task given was to develop the capability of making Earth observation systems on that. We started with developing an airborne multispectral scanner, as it is called. It was a 4-band camera, which is similar to multispectral scanner flown by the US in the satellite on that. This was extensively used to collect data, and this data was given to the computer people to convert into data products, and then to the application people to analyze it on that. Now, this was done in a very systematic way. We have taken imageries number of places. Initially, before the development of the multispectral scanner on the airborne, we used cameras using the film. Of course, that is now outdated. Now nobody uses that. Now then, what happened? We have come to a situation where the Aryabhatta was launched. When the Aryabhatta was launched, then after the launch, then even before the launch, I would say, Professor U.R. Rao and Professor Dhawan was wondering how we will proceed further with the satellites. So they decided we should have an application satellite. But then we have to maximally use what is available as a standby for Aryabhatta. And therefore, Aryabhatta was a low Earth orbiting satellite, as a spinning satellite. They thought it is the best thing is to use for remote sensing. So it was decided the next satellite of the India was a remote sensing satellite, and it seems that 2 days after the launch of the first satellite, there was a MOU signed between the India and the USSR Space Agency to launch the second satellite onto these things. So this satellite had a camera system which is developed by the Space Application Center, which was a spinning satellite. So it is very difficult. You can imagine you take a photograph on a moving system, how difficult it is. But then we made the two-band camera system. I would say this was much more complicated than the later cameras which we have developed. And this had a very high voltage, about 14 kilovolts, which has to be taken care without any problem under vacuum, etc., etc. So once the satellite was launched, one of the first time the camera could not be operated because of the arc. But we did a simulation experiment. We immediately found out what the problem is, and after a few months, it successfully operated on that. So that was the first spaceborne system what we have developed. In the meantime, we were looking ahead of what are the technologies. The conventional technology was using what is called an optomechanical scanner, where a mirror scans the surface of the Earth, and the spacecraft movement gives you successive scan lines on that. Then a committee was set up to define what should be the next operational satellites. So the committee at that time looked at many things, and we said that we'll go by the known technology at that time, that is using an optomechanical scanner. And the first office order by chairman was to use optomechanical scanner as one of the payloads. And considering our experience using solid-state devices, that also was included. But then, by the time we have demonstrated what is called a charge-coupled device, which could be used for imaging. I would say the first airborne system by Germany was in 1978 or so, and we demonstrated its potential in 1980. In those days, when internet was not there, information percolation was very slow. I would say this high technology, we were concurrent with the rest of the world, which I consider is a great contribution and achievements. So I did a detailed study, and our team using this Ccd Camera devices, and we submit a proposal. I made a letter to then Director ISRO Satellite Center that if we want to go further, we should concentrate our effort on using a solid-state having a CCD. A committee was set up, and I could convince the committee, and therefore it was decided to have a CCD-based system in the first operational camera. That is one of the great step forward, because normally in the space, one is scared to take any new devices. You go by the, already experienced methods by which one goes on this thing. We have the IRS-1A launched with the what we call a LIS camera, linear image self-scanning camera, which there were two cameras, one with about 70-meter resolution, which was like Landsat MSS, another with about 35-meter resolution, which is close to TM sensor or camera on board a Landsat. So the idea is the people who are using Landsat data now can use very close to this and find out what is its potential on this thing. So this was the quality of the image was excellent, because the CCD camera has got a specific advantage which the optomechanical scanner did have. So it has outsmart the performance of the Landsat MSS. And therefore, in 1995, when we launched IRS-1C, it was the highest spatial resolution 5-meter camera in the world. So that is, till then, the the highest spatial resolution was the French camera in the spot, was 10 meter. Let me digress and tell how this all came about, this high resolution camera. So Professor Rao was taking a review that what is the next step forward after IRS 1A and 1B. So we said that there is a need to go for a middle infrared and explained how it is the thing. And he asked, what about the panchromatic camera? That is, panchromatic means in black and white with the spot add with 10 meters. Somebody from the group said we should go for a 10 meter camera panchromatic. Rao was very upset. I don't want you to be followers. Don't tell me you can do what others can do it. Can you do better? So he looked at me and said, George, can you make 5 meter? It was a big challenge. There are no known systems, but we took up the challenge. And the story I am telling is, once a challenge is given to a team who are dedicated, they can come up, rise to the occasion and provide it. In 1995, we made the first high-resolution civilian system anywhere in the world. Now, I just want to digress and tell the Yashpal's thinking of having all facets in one place. Now, we have been talking about what are the new development of the sensors to be done on that. So at that time, we used to interact with the application people. One of the major applications of remote sensing in India at those days and even now is considered is finding out crop production estimation, area and production estimation. Now, to find out the area is relatively simple. Production, you should know how much quintal per hectare you can get. You require the remote sensing observation during the growth cycle. In the whole of any of these crops, it goes up to a maturity and then senescence takes place on that. You need to make observation in all these stages, 5-6 times at least in a span of this. Now the issue is, in a country like India is cloud cover. And the remote sensing, what we have been using is optical and it cannot penetrate through the cloud. So what you have to do? You should be able to make repeat observation. But when you want to make a repeat observation, there are certain constraints. You require a very large swath or a width of the things, which those days, because of the technological limitation, is going to be difficult. But we found with this, our application scientists, even with coarse resolution of about 70-80 meters, but if you can repeatedly see every 5 days, it's going to be great. So we developed a wide field camera, which has later it is called the advanced wide field camera of AWIPS, which has got about 70-80 meters spatial resolution, but about 800 kilometers swath. This is what happened when the satellite moves in one. Because of the large swath, you can see the adjacent place. So every 5 to 6 days, you should be able to cover this. This turned out to be a very unique sensor. It was not available anywhere in the world. So even the outside India, US and Europe, people started using it. And there are a number of publications one can see using this system. So this is another innovations which we have done to meet the application needs. The point I want to make is, our idea is not to make the best instrument. Our idea is, our concept is, what is the best instrument to meet our application needs? It maybe incidentally may also become the best instrument onto these things. And later on, as far as the development of the sensors are concerned, one of the important application is height measurement. So for that, you require a stereoscopic viewing. That means you are able to see a third dimension using two eyes. So you require two cameras, or use one camera itself from different angle. So we decided to go with a two camera system with a 2.5 meter resolution as a cartographic thing. That's also first of its kind, using a regular stereo. That means two independent viewing at different angles on that. So that was also used in number of countries other than the India. Now the IRS won a launch. Now we have found out that our data has a utility outside India. So there were a number of ground stations set up so that this data is being collected and can be utilized by other countries also. Now this was done under those days, but what is called an Antrix Corporation, which probably you would have heard from Hegde, and they distributed this, and we set up all the ground stations and the software required for that and for collecting onto this thing. Now, from then onwards, we have now currently have sensors which capable of sub-meter capability, which I think around go to 0.25 meters or so, about 25 centimeters of those things, which has got a tremendous potential in urban planning and of course the other strategic applications on that. So if I would say that India started with a very modest system of 1 kilometer, now at par with the rest of the world in providing data of the imagery to the world, if somebody wandered onto it. But I would also correct and say currently these type of systems are now commercially available because of the strategic importance. So the large number of private companies are developing this, but our is specifically for our own, meeting our own requirement on this thing. Another area ISRO has plunged is planetary exploration. See, that is a brainchild of then Chairman Dr. Kasturi Rangan. He said that we should find out our ability to go to other planets. So the first step was going to moon. Now some people will question why a country like us to go to moon. But I would like to say any technological development, the fruits you will see very much later. And the moon is going to be a resources both on economical and statistical. And from the economical as well as strategic. Waiting for that. Sorry for this strategic reasons on that. So you cannot be lagging behind. So therefore, there was the first step towards going to other planets and having our own food, put it on there. So the committee was set up to define what type of systems can be there in our first satellite around the moon. I had the privilege of chairing that committee, study team, and we come out with a set of instruments. These instruments were to make scientific observations as well as the imaging. So at that time, I talked to the chairman ISRO, said this, let's make it a science mission. So we can call for international participation, which normally happens in NASA and ESA, etc. They invite international participation, and this is a good proposal. They will allow some space for that. So we made an announcement of opportunity, There's a number of proposals, and we have shortlisted, and these were put in the satellite onto this thing. So what I want to say is, whenever we made a scientific exploration of the moon, so we, at par with the rest of the countries, invited proposals to put it on that, and that has become an international mission, if you want to say, though even the whole satellite and every aspect is always on that thing. That time itself, we have the study team looked into our possibility of going to Mars, because it was not to stop with that, going to Mars. And one of the experiments there was an imaging camera, a stereoscopic camera on that, so that the systematic mapping of the moon can be done. The moon has been mapped in centimeter level by astronauts landing on that, and a very coarse level, but never taken a systematic total coverage of the moon on that. This is the first effort in that direction. Why that is important is, if you want to do any development, you should have a base map. In India, if you want any development, you go Survey of India to have the base map. That was the purpose. But the satellite, unfortunately, it didn't last for an year, which we have designed. But still, most of the areas have been covered on that. So we have now capability not only cover India, cover the Earth, but other planets. And later, we have this camera system and other things onto a moon, to the Mars mission, where they have been using systematic measurement of the imaging of the Mars onto this thing. This is what broadly the sensor development onto this thing. But I should say that the ISRO's effort does not stop by generating imagery. And in fact, as Professor Sarabhai put it in, how we can use it for national development. So one of the major thrusts right during Sarabhai's time was to involve the user agencies. Those times, Professor Sarabhai himself wrote to a large number of administrators to make them know what the space can do. So there was a meeting held in Delhi. There were 100 administrators, policy makers were there, which during those days were a very good number, and Sarabhai himself addressed to him. And so that culture, take your end user along with you, is continued the successive chairpersons on that. Now, as I mentioned earlier, the first experiment, which is called the how to find out the acreage and production, was done with Agriculture Research Institute. And later, before a launch of a satellite, there was a utilization program. So we have Bhaskara utilization program, where you involve the actual end users, you make a simulated data and tell them how you can use it on this thing. Similarly, you have IRS utilization program before the launch of IRS. And when we had the ocean satellite, we not only had a utilization program, we had MOU signed with the 7 research institutions and operational agencies, that how you will use the ocean data for the end applications on that. Now, I would say that with this type of effort, now we were able to transfer the technology to the end users. Now, to give 1 or 2 or 3 examples, the forest department, they have a mandate to find out extent of forest for every few years. Now, they were using black and white photographs on that by aerial survey, sampling. Now, we have demonstrated using satellite imagery how you can enumerate the forest cover, the whole of the country. Now, the Forest Survey of India, they carry out this independently. The technology was developed along with them. Of course, initially there were some, discrepancies. These have been scientific and technically we have been solved on that. The other major area in which ISRO has developed is the production of various agricultural products before the launch, before the harvest. This has got a tremendous economic value. That means if one finds out your production is less, okay, you can take advanced planning to import or take any other necessary action. But if the world knows that your production is less, they will jack up the price. So this is a very important thing. Now, this technology has been transferred under the NAE's Department of Agriculture, which is called a unit MNCF, I don't remember the full form. And they now generate the production of wheat, rice, and a few other cereals and cash crops much in advance, at least 3 weeks in advance of the harvesting onto this thing. This is one thing you can say where the actual activity has gone to the end user on that. Other area is the potential school for fishing. This is also developed at the Space Application Center. See, what happened normally, the fisherman takes the boat and go out with the past experience to find out. We have found out the fish accumulation take place where there's a gradient of phytoplankton and there's a temperature gradient. This can be found out using satellite imagery. Therefore, we can tell them where is the potential school fish. So you can go them and fish instead of looking around onto this thing. Now this is an operational system. National Institute of Oceanography in Hyderabad, they are the prime agency collecting data and distributing it to all coastal areas. Now they have a board in which it shows that which is longitude and latitude. You can go and fish the things. So they move around with the GPS, which now even the mobile has got, and go there and catch the fish. Now this has tremendous economic potential, and in fact the point is that even if it is not available, they will just say where is the data on that. Now this is also transmitted by using radio on their own languages on this. So I thought these are a couple of examples which you can show that the remote sensing technology has gone into the grassroots applications of that thing. So this is thought what I could talk about. As I said that the first camera system for Bhaskara was, we have a peculiar requirement. We have to look at two spectral bands or two colors. One is in the visible, other in the near infrared, which is not visible to human eye on that. So you do not get this type of cameras easily on that. So we have asked a company in France to design one for us, and that they did it very well. Probably this is the first time similar such type of cameras used for Earth observation cameras on that. When we come back to actual operational system, one gratifying thing is, with time, we were able to indigenize all these things. Now, initially, our idea, all of ISRO is don't develop everything and spend time. Wherever you have the design, try to get it from outside wherever possible and indigenously developed. So, the lenses for the CCD camera which has a new design concept compared to the erstwhile things. That means they used to have one big camera, telescope, and split the beam into 4 or 5 colors. We use 4 separate cameras, lenses. Just the advantage, each can be tuned specifically to their capability. So the quality is much higher on that. Now we have indigenous capability of developing these cameras and also aspheric mirrors. These are all done by Leos in the Bangalore. And even now CCDs we have the ability to develop on that thing. So we have not only have an indigenous design capability, which I would say is par with best in the world, we also have a capability to the component level to fabricate and make it onto these things. And along with that, another very important thing is characterizing. See, testing these things is very, very important because you have to see that it meets the N specifications on that. So we have developed an elaborate laboratory capability here, which has, I would say, can be compared to the best in the world. There's a very large integration facility and complicated or complex instrument to test. See, if you want to test a camera, the test instrument has to be better than the camera. So you have to really make test instrument of at least 1 order of magnitude better than the camera to test it. These are some of the other achievements which we have done on that thing. I would say currently we are at par with anywhere else in the world to system design and fabricate these cameras, design and realize these cameras. I would also digress one point which I have not mentioned earlier. See, we realize the potential of microwave. See, the visible has got a limitation that it cannot see through clouds. It cannot see at night. Microwave instrumentation see through day and night. So this microwave technology is very complex. But we knew this potential. So even in the Bhaskara satellite, we had a microwave radiometer, which essentially measured the radiance coming from the Earth in 2 bands. And this has been used to find out the atmospheric phenomena. So parallelly, we were developing, which is called a side-looking airborne radar, and for the aircraft, so that which give you the familiarity. So all ISRO programs, what we have is you do it in a learning phase, then do it in an experimental phase, then operationalize it. So the 3-stage one we go: learn, experiment, and operationalize. Then, the side-looking airborne radar has a problem. We cannot get a very high spatial resolution. So what people do is a synthetic aperture radar. Now, India has the capability of building in synthetic aperture radar with a very complex instrumentation. And we had the first satellite launched using which has a capability, different modes it can operate, different ways of polarization it can operate. So that is another day and night technology. So that also ISRO has mastered on that. And that from the application point of view, as I told you, you have the issue with the cloud cover. So that will not happen onto these things. So that is another area which you can do it. So I think that is it. Probably what I told right now can be interjected along with the sensor thing. So that may look little more continuous on that. Let me conclude by reiterating what Homi Bhabha said in 1962. We are in the same ground floor as the Western nations. They are leading us only by about 4 to 5 years, referring to launch of Sputnik. Hence, in the course of 10 to 20 years, we must be able to equal them. Well, in the field of remote sensing, I could confidently say we have not only equaled them in applying the remote sensing technology for national need, we have, I would say, even may have excelled them. Thank you.
Thank you for listening in to this episode of the NewSpace India podcast. If you enjoyed this conversation, please share this episode with anyone you believe will enjoy listening to it. You'll be able to find the NewSpace India podcast in any of the podcasting platforms that you may be using, including Apple, Google, Spotify, YouTube, and others. Do subscribe to the podcast in case you want to receive new episodes automatically. I'm grateful if you're able to leave a rating for the podcast, which will help others discover it. Thank you for listening in again, and the next episode will be out in the next 2 weeks as usual.